Here we are going to present the world's ugliest slide to detail the PartBuilder pin data to symbol flow diagram. So the deal is we start with the pin report on the left, we go through the whole process, and we end up with the symbol files that we want down here on the right. So let's start over here. A couple of things. So these things highlighted in white and green, the property editor, the pin explorer, and the SDL editor, those are interactive GUIs that can pop up in the tool that we can do things with. So the property editor we can set up and create the property values. The SDL editor we can use to take the SDL template file, we can change it and save it as a user SDL file. And then the pin explorer, there's some, just for clarity, it can open up the internal pin data and let us look at it. And it can also help us build rename rules and pin override type file. We're going to assume those are set up already. So we're starting from the right, and we have the pin report file, which can be a spreadsheet, an IBIS model, a BSDL file, any kind of the FPGA reports, the physical or the logical, the Cadence Part Developer export, Ultra Librarian PDT file, any existing Allegro HDL symbol, an ORCAD EDIF symbol, or a Mentor symbol. So those are our inputs, and the first process that runs from PartBuilder is the pin data extraction. And that's when we hit the run, the get pin data button. The next function that runs is pin rename, and that uses the rename rules, which can be provided inside the GUI in a line, or there can be a file that points to a bunch of different rules that create the pin renames. Then the pin type override file is next. So the pin type overrides are applied to the renamed pins. That's important to realize. When we go through these steps, we end up with a database that stores the internal pin data for us. And so that's the first step. So you hit the Get Pin Data button on the GUI, and you end up with this internal pin data. From that point, we can use the Pin Explorer to look at those pins. Okay? And if we want, we can change the pin type override, we can build the pin type override file, and then we can run back through this first pipeline, step of the pipeline. Once we have our internal pin data, we can run SmartFrac. And what SmartFrac is, as I always explain, it's what an engineer or a librarian would do if they got their pin data. They would get a spreadsheet and sort it as efficiently as they could into symbols that they want. So SmartFrac reads all the pin data, it finds the diff pairs, it finds inputs, outputs, and it also finds FPGA information. So if it can detect it's an FPGA, it'll find the banks and split the symbol into multiple banks, or the symbol description language to describe multiple banks. And the output of SmartFrac is this SDL template file. So that's the first file that gets created. And then the user is responsible. This is the big step. The user takes the SDL template file, uses the SDL editor to create the user SDL file. Once we switch over to the user SDL file, SmartFrac can run and touch that SDL template file as many times as it wants, but it won't really touch us because now we're here. So now what we have is we have the internal pin data, and now we have a user SDL file. So the next thing we do is we actually run the pin mapper and the map pins to symbols operation. And what that does is this operation. It expands the SDL file. So if there's any loop directives in that file or any variables or anything like that, it'll expand that into an intermediate file called the expanded SDL file. Then the SDL reader goes along and reads that expanded file, and it builds these pin map rules. So now we have a set of pin map rules, and we have the internal pin data. So then the pin mapping function runs, and it goes through each pin, and it looks at the pin map rules, and it builds an internal symbol format. So we marry the internal pin data and the pin map rules into an internal symbol format. And this is one of the powers of PartBuilder, is that it keeps the pin data separate from the pin mapping rules. So these rules are mostly just done by pin name. They don't care about the pin type or the pin number. The pin map function looks at these pin map rules, and it fits these pins into an internal symbol format. And then the next step is when we hit the build symbols is the symbol generator. That takes the internal symbol format, and it knows how to create the symbol files for any of the EDA tools that we have for OrCAD, Cadence, Mentor, Altium. We just added Zukin. Part of the input to the symbol generator is also the property editor. So there's a property local control file that this kind of is a bidirectional thing. The property editor helps us build that prop local control file. But this is how the properties get added into those symbol files. There should be another storage showing internal property storage, but I just can't fit that in this diagram. And that pretty much explains how we go from a pin report all the way back to the symbol files.